So let's continue to look at our unit circle. As we look at it here, if we were to take a point on our unit circle of radius 1, if the radius is 1, then this point here must be 1 along the x and 0 on the y. So the coordinates of that point are 1, 0. But we said earlier that if we had an angle theta, and here at the moment our angle theta is actually 360, then we could also say that the coordinates of this point here could also be represented by cos theta comma sine theta. And if we were to plug in our theta 360 in here and here, we would see that the cos of 360 is 1 and the sine of 360 is 0. This point here, where theta is 90 degrees, okay, coordinate-wise it's 0 along the x and 1 on the y, 0, 1. But also, in relation to the trigonometric ratios, it's cos theta sine theta. So cos of 90 is 0, sine of 90 is 1. So we can represent that position either way. Okay. If we go to this point here, which is minus 1 on the x and 0 on the y, but also is represented by the angle of 180, then the coordinates of that point are minus 1 comma 0, or we can find them by plugging in theta, cos theta and sine theta, which is minus 1 and 0. And we could also choose this point here, which is 0 on the x and minus 1 on the y, and that's 270 degrees. We could see that we can represent that those coordinates, the coordinates of that point, as either 0 comma minus 1 or the cosine of theta, the cosine of 270, comma sine 270, which is 0 comma minus 1. So we can just see there how we can relate the coordinates of any point on the unit circle by finding whatever the angle theta is, by finding its cos and its sine. It's cos and its sine, cos and its sine, cos and its sine. And it's a good time now to mention, I suppose, the fact that in drawing that unit circle, we can see that it has 4 quarters or quadrants: the first, the second, the third, and the fourth. And something to note about these quadrants is that in this first quadrant, our theta is between 0 and 90. And the tan of any angle between 0 and 90 in this first quadrant will always be positive. Okay, and here in the second quadrant our angle is between 90 and 180, and here only the sine of any of the angles in here will give us a positive value. The tan and the cosine will give negative values. Down here, if our theta is between 180 and 270, then only the tan of any angle in here will be positive. The sine of any of these angles will be negative, and the cosine will be negative. And finally, in the fourth quarter, where we go from 270 to 360, any of the angles in here, only the cosine of any of these angles between 270 and 360 will be positive, whereas the sine of any of these angles in here will be negative, and the tan will be negative. And from that, we can have a way of devise a way of kind of remembering that rule, and that is to say that we can use the letters C, A, S, T, cast. This means all the trigonometric ratios of all the angles between 0 and 90 are positive. This means only the sine trigonometric ratio for the angles between 90 and 180 are positive, the rest are negative. within here from 180 to 270, only the tan of those angles are positive, and when the angle is between 270 and 360, only the cosine of that angle is positive, the others are negative. And we're going to see how to apply this rule in a second. Because there comes a time when we make use of these rules or facts to find the trigonometric ratio of an angle between 90 and 360. Up to this, really, we've been dealing with angles in right-angled triangles, and basically the angles we've been dealing with have been up to 90 degrees. Okay? However, they've been represented in a right-angled triangle. Any angle we've looked at has been less than or equal to 90 degrees. Okay? But, we've seen from the unit circle that, the angle can be, yes, anywhere between 0 and 90. It can. And we can use our trigonometric ratios, and we'll find what the sine of any angle here is, and the cosine and the tan. But there are angles that go up to 360 degrees. So let's see how we can find or represent an angle greater than 90 in, say, third form. Okay, so just get rid of this. Okay, so a typical type of problem. Find the sine of the angle 180 degrees. Find the trigonometric ratio of this angle that's between 90 and 360, 120 degrees, in third form. Okay? So this is an approach we use when we try to find this value. And the first thing is to actually draw the angle. Okay, so draw your x and y axis. Draw your theta, which is to 90 to 120. Okay, and that's known as the terminating side. So this angle is 120 degrees. So we can see what it looks like. And then we take note of this second angle that's known as the reference angle. Now the reference angle is that angle between the terminating side and the x-axis. Okay, so in the first quarter, that's the reference angle, that's the terminating side, that's the x-axis. In this quarter, if that's the terminating side, that's the x-axis, this is the reference angle. In this quarter, that's the terminating side, this is the reference angle. And in this quarter, that's theta, and this is the terminating side, this is the reference angle in here, between the terminating side and the x-axis. So if I just shade in the terminating angles, the four of them are actually there. Okay? So, going back to our problem, to find the sine, or represent the sine of 120 degrees in third form, draw your angle 120 degrees, mark the terminating side, and work out what the reference angle is, the angle between the terminating side and the x-axis. And in this case, that must be equal to 60 degrees, because that's 120. The straight line angle is 180, so this must be 60 degrees. Okay, and the third step then is to write or equate the original, what we're looking for, sine of 120 equal to, and we'll leave a box here, empty box, to hold a sine in a minute, and we'll just equate the sine 120 equal to the sine of that reference angle. Okay, and we're nearly there now. It's nearly good enough to say that the sine of 120 is equal to the sine of 60, but we just have to be mindful of this sign here. Is it positive or negative? And to do that, we need to refer back to our cast rules or facts that we met with earlier. Okay? And the way we do that is we draw our CAST. We note where our angle is. It's in the second quarter. In the second quarter, we said earlier, only the sine trigonometric ratio is positive. This is a sine trigonometric ratio, so actually our sine will be plus, and it will be plus sine of 60. We can then refer to our log tables, which is where we are here. We can refer to our log tables, and we can say that the sine of 120 is equal to plus the sine of 60. In our log tables, the sine of 60 in surd form is root 3 over 2. So we can express sine 120 degrees in surd form as positive sine 60, which is root 3 over 2. Second example here. Find or write cos 225 in third form. Represent this angle that's greater than 90, okay, but less than 360 in third form. Okay, first thing is to draw our 225 degrees, and that brings us through the 180 and somewhere in between the 180 and the 270. That's in the third quadrant. Okay, and that's our terminating side. It's our x-axis. So we need to now note what our reference angle is. And our reference angle really is 225. It's all of this minus 180. And our reference angle is 45 degrees. That's 45 degrees. Okay. Now we equate what we're asked, our cos 225 equal to some sign we need to find. We'll leave a box there for that. Cos of 45. Cos our reference angle. Okay. We need to see where we stand with this sign. So we draw our cast. Okay. We look for where our angle is. It's in the third quadrant, and only the tan trigonometric ratios are positive. All others are negative. Okay, so for our case, we must then deduce that cos 225 is equal to negative cos 45. The log tables for cos 45 is 1 over root 2. So cos 225 is minus 1 over root 2. If you were to look in your calculator, cos 225, you'd get a value which would be equal to the same as minus 1 divided by the square root of 2. But in this case, we've represented cos 225 in third form, which is minus 1 over root 2. And finally, we'll finish with a problem that tells us or asks us if the cos of A is equal to minus 0.4153 and A is between 0 and 360 degrees, find that angle A. Okay, so cos A is equal to minus 0.4153. So to begin with, we'll just ignore the negative sign and we'll find the reference angle, not this time by drawing, but this time saying that if cos A equals this, our reference angle is the cos inverse of that value itself, ignoring the negative sign. Okay, and we'll get our reference angle as 65 degrees. Okay. Now we'll become mindful of the fact that cos A is a negative value. Okay, and we'll draw our cast and we'll say C-A-S-T. Okay, cos is positives there, all are positive there, only sine is positive here, so a negative cos will be in here in second. Only tan is positive there, so a negative cos will appear here, and we have a negative sign here. So our angle appears, our reference angle is in the second quadrant and the third quadrant, okay, 65 and 65. So the angle A that we're looking for is actually two angles. The first angle is to here, it's 180 minus the 65, it's 115, and the second angle is 180 plus the 65 is 245 degrees. So in summary, given that cos A was equal to minus some value, we found the reference angle by finding the inverse of that value, 0.4153, ignoring the negative sign. We have a reference value of 65, and because this is negative and this is cos, we see that cos is positive here, cos is positive there. It's only negative in these two quadrants here, okay? So actually A has two values. It's there in the second quadrant and it's here in the third, okay? So A can be this first one, the first angle is 115, or A can also be equal to the second one in the third quadrant, 245 degrees.